So my name is Imad Mouline. I'm the CTO for Gomez, the web performance division of CompuWare.
And my name is Ryan Breen. I'm the Vice President of Technology at Gomez.
So I was talking to Jesse about 6 weeks ago just to talk about how things should be done here at Velocity. He was saying something like, sponsor, vendor, product pitch. I didn't quite get the context. Was it you want me to do a product pitch?
Yeah, that always works.
Just that works well with this audience, right? No. So what we're going to do actually is talk to you about a few trends and best practices out there. But the way that we're going to do it is by sharing some data with you. So hopefully that should be interesting. And most of the data is going to be aggregate data. So instead of looking at one site at a time, looking at lab stuff, we're going to try to see what it looks like out there in the real world, and then drive some interesting conclusions, hopefully, and maybe a few controversial things here and there about what's perceived today as best practices, and see what you guys think. So the first thing that we're thinking about is this whole relating performance to business, to the bottom line, to customer behavior. Does better performance really impact the bottom line or customer behavior? So, here at Velocity, you've heard a bunch of different data. We thought we'd take a slightly different cut at it. So we looked at a lot of data. But what we're going to show you here is something that's interesting. What is the impact of performance on page-level abandonment, right? So people who are not going to wait around for the page to load. So we took a look at 500 million user interactions across 200 different sites, and then looked at the same users or the same sites, and then looked at the performance of specific users using our real user monitoring, and then asked the question, did they wait around for the page, or did they click on the stop button or abandon the page? And the results were interesting, because what we thought originally was, is there a chance that we can find out if there's a correlation between the absolute performance? So, hey, if you have a response time of 3 seconds, then your abandonment rate would be this. The answer is no, because the sites are way too different. But we found an actual correlation between that delta. If you were to improve the performance by 2 seconds, you could decrease your page-level abandonment rate by 8%. And it goes all the way to a whopping 38% for those users who had an 8-second better performance. All right, so that's our contribution to the bottom line impact of performance. So what we're going to talk about today is a little bit of, again, the cloud in general. But before I do that, here's one assertion that we're making. The browser is becoming the integration platform out there. Okay? Applications are being built at the level of the browser. Lots and lots of different third parties.
Yeah, so you're really only ever seeing the application when you're inside the browser. So if you're testing, if you're trying to understand the performance that your users are seeing, you need to be inside that browser.
So we asked a quick question by the numbers. Again, looking at across 3,000 different companies, tens of thousands of web applications and workflows and customer journeys. And we asked the question, on average, for the typical business-critical transaction on the internet, how many different hosts does the transaction require in order to be successful? Any guesses? And Yarowan, you can't answer that question because you know the answer. So just to spice it up a little bit, we decided that we're going to look at it by geography, simply because, you know what? Different people in different countries might have a slightly different way of building applications. So here are the numbers. Again, this is across banking, financial services, travel, media, across the board. On average, it's around 8.5 to 8.8 different hosts that are required to be called directly from the browser to make the transaction possible. And of course, there are a lot more servers behind each one of these fully qualified domains. And that number is increasing. A few months ago, that was closer to 8 as opposed to 8.8. So again, the browser is becoming the integration platform that's out there. And this is why it's absolutely key that you're going to look at your performance from the perspective of your end users, where it's built across the board. Now, the next question that we asked, since we're talking about cloud, is how many of those are actually hosted by a cloud provider? So again, across an entire transaction, how many of those transactions are requiring at least one object, one piece of content that happens to be hosted in the cloud?
Yeah, and let's just see a show of hands. How many of you are actually using cloud services?
All right, there might be a slight disconnect here because here are the numbers that we see. Again, what is the percentage of transactions that are pulling in at least one object that's hosted on this guy, in this case, Amazon EC2? So not much in Singapore, but as you'll see, in some other places, the numbers are fairly big. All in all, about 20% of all the critical business transactions that we see out there are pulling at least one object or calling at least one service that happens to be hosted on EC2. These numbers just blew us away. Didn't expect them to be this big. And most of these companies don't even realize that they're depending on a piece of content that's running out there in the cloud. 6 weeks ago, that total number was 16.8%. 2 days ago, 19.6%. That's also the growth that's absolutely fascinating. So a couple of different characteristics about the cloud that you might already know. Number one, the cloud is opaque. Good luck trying to figure out exactly what's happening outside of your instance in terms of the health of the cloud provider. Secondly, it's shared, which means that there's a very good chance that somebody else's application that's completely independent from yours might actually impact your performance, simply because they're using more than their fair share of resources. No matter what providers tell you, virtualization or otherwise, you cannot completely seal off one application from the other. So we decided to put that to the test. So for about 17 months now, we've been monitoring the performance of this particular application, a reference application that looks exactly the same across the board. We've deployed it to a whole bunch of different providers and have been monitoring it constantly. We've put the exact same load on it, so there are no fluctuations in load. There's no change to the application. We just decided to see, again, are there changes in terms of performance across apps or across providers?
Yeah, and I think it's really interesting just to note the level of the inter-cloud variability and also just the level of intra-cloud variability. I mean, same provider, but just within the span of a day, you can see some very large fluctuations in performance.
So we also took a look at availability. Now, in order not to call out any or to protect the innocent here, I took an aggregate view of availability across all of these different cloud providers. Of course, we also took a very strict definition of availability. Our application had to work from an end user's perspective, and that's it, okay? As you can see, you probably wouldn't accept this level of availability in a typical business application. But again, this is a very simple app that we put out there. No real mitigation strategy or any sort of real operational view into what's going on other than letting it run and seeing what's happening. So the cloud is opaque, right? You're not really seeing what's going on. The providers aren't telling you what's going on. Our view, of course, is in order for it to really work, in order for you to understand what's going on, the only way to truly understand whether your app is performing is to look at it from that browser perspective, from the very consumption point. It's shared, and this is where it gets interesting. When it's shared because another application can have an impact on yours, how are you ever going to tell when there's a performance problem, whether it's your problem or whether it's the cloud providers? There is no real way of doing that. So our contention here, our view is that the way to do it is by building in some collective intelligence. Have the community come together and aggregate all of your data so that if you have a performance problem, you can see, is the community seeing the same thing? Are you seeing the same symptoms across the board or not? So as part of that, we've put together a little community site called Cloud Sleuth, cloudsleuth.net. So it shows you, by the way, that the performance of that application that we talked about across various cloud providers. You can see it in real time. You can drill into it, et cetera. It's just a community site. But what you can also do is if you have a cloud application or service, is you can actually register that URL. You'll get some free monitoring out of it. But at the same time, you'll be contributing to this collective intelligence so that when we give you back that information, you'll be able to see, oh, look, I'm having an issue. Let me look at my symptoms. Is that community also seeing the same symptoms from that data center, for example, that region, that availability zone? And as soon as we have critical mass, we'll share that data back with the community, completely open, completely free. So, enough bad news, right? The cloud actually offers some interesting optimization opportunities.
Yeah, so just a show of hands. Everyone's familiar with domain sharding, right? Okay, so
yeah.
Domain sharding, an optimization strategy that's been around for a really long time, really generated from a time when browsers were fairly limited in parallel connections. So, you spawn off multiple different host names, same content, you trick the browser into making a bunch of different connections. A nice optimization, which, when it's called for, can provide a huge benefit. But traditionally, it has come at a real price. You're still hosting that content. That content is still using your capacity, and at peak time, that could wind up being a constraint there.
So here we just tried it out. What if you could actually get this optimization for free, right? Generally, if you're doing sharding in your own environment, chances are you're going to pay for it in one way or the other. You're going to reduce your capacity at peak time because you're making so many different connections. So in this particular case, what Ryan did is create an application did a little bit of sharding, and with Amazon, put it on S3, put each different shard in a different bucket. What's the goal? Or what's the result?
The nice thing about this is any bucket in S3 is its own host name, so it essentially comes for free, and so you do wind up seeing in this specific application, in this specific scenario, that's a 50% performance gain.
50% performance gain, and what's the extra cost in this case?
Nothing.
0, because it's the same amount of data. You're being charged by the volume of data that you're transferring. So there is such a thing as a free lunch in this particular case. Now, what happens if it's not necessarily static data? Just putting your data in different S3 buckets is not good enough.
Yeah, so if you have a potential scenario where you have a dynamic application where you might have an increasing volume of users coming in, hitting an instance, maybe something that's hosted in the cloud on EC2, if you have a scenario where you start to see the volume of users increase, you might start reaching capacity on that instance. What the cloud gives you is a really nice ability there to very quickly switch out a new instance and scale it horizontally, either automatically or manually based on what you're comfortable with, and then start partitioning your user base so some users come to the new instance and you avoid completely falling down in a case like that.
And in this case, of course, you're only paying for it when you really need it, when that capacity is reached on those particular instances. Again, great possibilities here in the cloud for getting that additional performance boost, but without the associated cost. And as you can see, it works and works very nicely in terms of the performance boost that you get. However.
Yeah, so it's interesting always to sort of look at the optimizations we might have done last year and see if they still apply. So when we talk about sharding, I made the point of, it came from an era where browsers were fairly constrained in terms of the number of parallel connections. That's really not the world we live in anymore. And we're almost sort of swinging to the other side of the pendulum where you might have a browser with a lot of connections. So mobile Safari, as an example, over 3G on an iPad. So you're in a situation where now you're potentially creating too many connections and you run into a performance constraint. We actually saw a major news site that's a customer of ours, very heavy user of sharding. We actually found that by removing sharding, in almost all scenarios, the application performed better and substantially better in some cases. So just a lesson to always sort of understand that yesterday's optimizations aren't necessarily gospel because the realities on the web are always changing.
So we decided to also take a look. Let's look at that aggregate information again. This time we looked at a couple hundred sites, about 466 million page measurements, and asked, is there a difference across different browsers and devices? And we looked at two different metrics. The load time, which is the raw load time for the entire page to load, and the perceived render time above the fold. How long did it take for that viewport to actually fill up? Again, that's probably a whole entire talk to talk about how to optimize that. But that improvement from the perceived render time to the load time changes radically from browser to browser. And as you can see some interesting optimizations there that are possible from the perceived render time to the load time, but also some improvement from version to browser to version to browser. But you can see still a huge difference across different browsers. The browser itself has a huge impact potentially on what that performance is. And again, this is real world, real life, no lab, real users that are out there. So, a couple of key takeaways. Number one, as we said, applications are becoming more composite. The browser is the integration platform of choice today. And believe it or not, most of you are using the cloud whether you know it or not, because some of those third parties, unbeknownst to you, are running out there. So for good or for bad, you have to, in a way, deal with it. The cloud offers some amazing new opportunities. But what I've got to tell you again is the performance optimizations that were good enough yesterday are probably no longer good enough today. So you have to constantly revalidate them. It's not just about sharding. Talking about reducing the number of HTTP connections. Is that always a good thing? Probably. Should you always concatenate your JavaScript files, for example? It depends. You might actually make a page faster, but you might do that at the expense of slowing down an entire workflow for certain pages. Think about that for a second before you actually rush into those types of things. Do your testing, your validation, both synthetically, but also with real users, so you know exactly what impact you're having in the real world. So constantly revalidate all of that. And then lastly, this collective intelligence-driven view of the world is going to be key in determining exactly whether an issue is due to your application, your little environment, no matter how big it is, or that incredibly big shared environment that's out there, cloud or otherwise, given that there are so many different third parties. So I'd like to invite you to visit Gomez.com/velocity. Some of these tools that we talked about, like Cloud Sleuth, you can link straight from there. There's a nice little iPad waterfall test website. If you want to test whether your optimization is really going to work on an iPad, you put in your URL and you'll get a waterfall for free. And then a multi-browser, multi-location test. Put in again your URL and you'll get back a couple of different tests or measurements that combine both multiple locations around the US as well as multiple browsers to see where your bottlenecks are. Thank you.
Thanks.